In this video, we'll analyze the replacement of a standard efficiency with a premium efficiency motor. I'll move to the energy screen. From there, I'll select energy and the end use is motors. We see the method 1 motor calculator, the simpler method. I'd like the more capable method, so I'm going to move to method 2. Here we see the standard base and proposed case situation. I'm going to begin by specifying my base case motor is a 50 horsepower standard efficiency motor. So I will choose horsepower and 50. Next, I will accept the fact that the motor has a full load efficiency of 91.1%. Ratscreen has tables to deliver that information, but I will specify that motor operates at full load at 1760 RPM. It'll slip back 40 from its 1800 RPM synchronous speed. I do know that that motor, in fact, is not fully loaded. In fact, it's running at about 75% of load, so I'll use a load factor of 75%. Now, the next input is quite important, load type, standard or centrifugal. A standard load has a relatively straight line relationship between power and speed, but a centrifugal load, meaning a pump or a fan, will often vary cubically power versus speed. That can have a big impact when you make a small change in the speed of a motor, large impact in power. We'll have a look at that at the end of this analysis. The motor we have here is operating for 16 hours a day. We'll go ahead and enter that, and we've now completely specified our base case. We'll copy base to proposed, and we'll proceed to modify the proposed case. So we're going to move to a premium efficiency motor. We had to do that because that's basically all that's available for purchase today. Ratscreen knows that that motor is about 94% efficient, but I know from that nameplate that that motor is going to be spinning at full load at about 1775 RPM. I'm going to go ahead and specify that, use the same 75%, but Ratscreen has adjusted that now for different loading here. And in fact, we see that that motor is consuming very close to the same power, even though it's more efficient for this centrifugal load. In fact, there's only about a 0.6% reduction. We can see what would happen if we ignored that centrifugal load. So let's go back to a standard load, and it actually suggests that we're getting about a 3.1% savings. And in fact, the loading on the motor is the same. So clearly, the centrifugal load makes a big difference when we're going from a standard to a premium efficiency motor. So how would we avoid that reduction in savings? Well, if this motor were spinning a fan with a belt drive and shivs, we could adjust the shift slightly in order to bring the speed of the fan back to the original speed. Now, we would be getting more flow at the higher speed, but if we don't need that flow, then let's move it back to where it should be. There's a great example of how to use the motor calculator Ratscreen to avoid unnecessary increases in energy consumption.